Welcome to day 6 of my Inventor I.O. 30 Days Lost in Space adventure. Today's lesson is going to be covering using analog inputs with a light-sensitive photoresistor. So this is a little bit different than what we've been used to. I broke down my entire breadboard because I'm not using any of the LED lights at the moment. So what this photoresistor will do is it will monitor the amount of incoming light, and then it will send a feedback signal to the analog input of the hero board between the values of 0 and 1023, which makes it a good candidate for using an integer value to monitor the amount of light that's coming in. I watched the majority of the lesson. I assembled the board according to the schematic. So what we have is we have our 5 volts coming out of our board, going to one side of the photoresistor. The photoresistor is non-polarity sensitive, so you can wire this in any direction. It doesn't really care, much like the resistor that's wired into the board next to it. So we have 5 volts coming into one side of the resistor. The other side is tied to an analog input, which is different than a digital input, where a digital input is either 0 or 1, and an analog input is 0 to whatever value it can take in. From there, I'm also tying the side that goes to the analog input to a resistor, and then from the resistor we go out to ground. So let's go to the computer and we will go over some of the code that I'm working with right now, and we'll go over some of the code that they have us working with to get the sensor value to output to our software. Okay, so the first thing that they have us do is they have us test out the serial.begin and serial.println functions. And what these do is these verify that the serial port is communicating with the board and that the board is able to send back the data that we requested in the form of a print line statement. So the very first thing we do in this exercise is we initialize a pin as an integer, and we say sensor pin equals A0, which means analog input 0. In the setup, we just do a serial with a capital S dot begin, and then inside of the parentheses we give it a 9600, which is sort of like a baud rate for the back and forth communication between the computer and the hero board. Inside of our loop, I just have a serial dot println for print line, and inside of the parentheses I put hello. Underneath that I have a delay of 500 milliseconds, and if we compile and upload this program, under tools, if we go to serial monitor, we'll see that every half a second the serial monitor is receiving a hello statement from the Arduino board, or the hero board. We can speed that up a little bit. And see that the output is much faster. You can also use serial.print with hello/n, which will give you the same result. /n gives you a new line. So if I go back to my monitor, you'll see that it's back to printing hello on a new line every half a second. With a /t, it will be a tab. When we go back to the serial monitor, we can see that the hello, instead of being top to bottom, is now printing out in a left to right fashion with a tab spacing. I went a little bit further as to create a sketch that had 2 for counters or for loops. So at the very top I still have the same data, the sensor pin integer A0 and the serial begin 9600 rate. And then inside my loop I assign 2 integer values of I and k, And then underneath that I have two for statements that will count I up to 10, and it will print out 10 hello statements with a tab, and then after it will print out 10 hello statements with a new line. So if I upload this and go back to my serial monitor, we can see how that is coming out. So it counts 10, counts 10, counts 10, counts 10. I can change the print to show you the difference. So now I have to go through and put in the code for the photoresistor. So I'll put that in off camera, and then I will come back and show you what that looks like, and we'll see how the board responds to the photoresistor with various amounts of light getting fed to it. Alright, so for the sake of my own sanity, I went ahead and I put in all of the code that he states to do initially, and this is just to get the photoresistor to respond to light sensitivity. And on the right hand side, I'm just gonna type it back in just to kind of get it into my head a little bit. So what we're doing initially is we are defining our sensor pin, saying that it's on analog input A0. From there, we're initializing another variable called sensor value with a default of 0 value. Inside of our setup section here, we have serial.begin with our data transfer rate of 9600. And then inside of our loop, all we're doing is we're saying sensor value equals analog read, and it's reading the analog value off of the sensor pin. From there, we're doing a serial dot print line. We're outputting the sensor value, and then we're delaying the output of each sensor value print to a half a second. So if we verify and upload to the board, when we go back to our serial monitor, we can see that it's outputting, right now it's outputting a constant value of 962 with a slight fluctuation to 961. If I put my hand over the sensor, you can see that the light level drops. If I turn on the flashlight on my phone and I point it at the sensor, we can see that it goes up. So it is working and it is feeding back. There's a little bit more to the lesson inside of the code example here. They want to use the onboard LED to turn on and turn off to let us know that the resistor is actually working without having to use the serial monitor. So let me pop that in real quick, and I will be right back to explain exactly what is happening. Okay, so I typed in the additional information. So what we're doing here is, again, we're defining sensor pin on analog input 0. We are telling we are defining onboard LED to 13, which is the pin value of the onboard LED. So here we say pin value of onboard LED. Sensor value is just sets default value of sensor. They didn't have me do the serial begin here with the 9600. I don't know if it'll make a difference, but I'll leave it out just because it's not written here in the code. In the loop section, we have the sensor value variable using an analog read to the sensor pin, which is analog input 0. We're then doing a digital write to the onboard LED to set it to high. We're delaying the value that is currently in the sensor value variable. So if we go to our monitor. Okay, so from the looks of it, without the serial begin at the top here, it will not output the value in our serial monitor. But I'll try that again. I'll comment it out. I'll re-upload. And we'll see if it will continue forward with the output value. So yeah, it's not outputting the value if I don't have the serial.begin. So I'll leave that in there. And then we should start seeing the data coming through. And what this will do is the more light that's on the photosensor, the slower the delay will be between the light going on and off. So if I cup my hand over the photoresistor, the light blinks faster, and if I put light onto the photoresistor, the light blinks slower. So this makes sense from a beginner standpoint, just a basic 5 volt going to a resistor, coming back out, sending analog data to an analog input, and then using the analog read, it will sense the analog value coming back from the resistor going into the input. You can do this with potentiometers as well. You can have 5 volts or 24 volts or whatever your voltage is on your equipment. You can also monitor analog values with a potentiometer in the same fashion, where you have a positive voltage going to the left leg of the potentiometer, you have your ground coming out of the right leg of the potentiometer, and then you have your variable value coming out of the center leg and going into the analog input. And as you turn the potentiometer clockwise and counterclockwise, you get closer to the maximum value of 5 volts, or you get closer to the minimum value of 0 volts. So this makes sense to me because I have wired up potentiometers in the past between custom guitar wiring and wiring up potentiometers for analog override controls on a CNC machine. I've just never done it in a C environment. So this is helpful in me learning more about C language and utilizing the Arduino boards and the Arduino IDE to take in this analog data. So that'll conclude day 6 for me. This was a quick one, but it was very insightful, and I think it was very helpful for me to explain it to you guys and just do it over and over and over again. I plan on practicing this more and more. more than likely we will be building on this circuit in the days to come. So I'm excited to see what day 7 leads into. But for now, I'll leave it at that. I'll mark my lesson complete, and we will see you soon.